Hello everyone, myself Abirami from St.Joseph College of Arts and Science, Cuddalore. Today our topic about Hadoop. Hadoop is a distributed framework for big data. Okay. In this session, we have seen about introduction to Hadoop and architecture of Hadoop and Hadoop industries. What is Hadoop? Apache top-level project open source implementation of frameworks for reliable, scalable, distributed computing and data storage. Hadoop is an open source framework from Apache and is used to store, process and analyze data which are very huge in volume. It is used for batch offline processing. It is being used by Facebook, Yahoo, Google, Twitter, LinkedIn and many more. Moreover, it can be scaled up just by adding nodes in clusters. It is flexible and highly available architecture for large scale computation and data processing on a network of commodity hardware. Hadoop. Hadoop is an Apache open source framework written in Java that allows distributed processing large data sets across cluster of computations using simple programming models. The Hadoop framework application works in environment that provides distributed storage and computation across clusters of computers. Hadoop is designed to scale up from single server to thousands of machines, each offering local computation and storage. Search engines. Okay. In 1990s, some of the search engines. In 1996, Meta Traveler, and then 1996 we have an Excite Search, and then 1996 Lycos, and this Hotbot, some of the search engines in 1990s. In latest and 1998 Google will be introduced, Google Beta, and 2013 Google will be introduced. Okay, what is an Hadoop? The Dong Cutting is an introducer of Hadoop, and Dong Cutting and Michael J. Cafrilla developed Hadoop to support a distribution for the Nudge search engine project. The project was funded by Yahoo. Yahoo gave the project to Apache Software Foundation in 2006. Then what is an Hadoop HDFS and Hadoop MapReduce and Apache HBase. Okay. Hadoop HDFS. HDFS is Hadoop Distributed File System. A data stored in a distributed manner in HDFS. There are two components of HDFS. There is a name node and data node. While there is only one name node, there can be multiple data nodes. HDFS is specially designed for storing huge data sets in commodity hardware. Enterprises versions of a software cost roughly $10,000 per terabytes for the full processors. In case you need to buy 100 of these enterprise version servers, it will give up to $1 million. This is an HDFS. Okay, what is MapReduce? Hadoop MapReduce. Hadoop MapReduce is the processing unit of Hadoop. In the MapReduce approach, the processing is done at the slave nodes and the final result is sent to the master node. A data containing code is used to process the entire data. This coded data is usually very small in comparison to the data itself. You only need to send a few kilobytes worth of code to perform heavy duty process on computers. The input data set is first split into the chunks of data. In this example, the input has 3 lines. Okay? The text with 3 separates into various formats. The key and value pass, then shuffled and sorted together. Okay. Then Hadoop HBase. This is an Apache HBase. This is a distributed storage system for structured. This is both structured and unstructured. And it's both using HDFS and MapReduce, and then name node and data node. It introduces task manager and job transfers. All will be done. Okay, what is an Hadoop? Hadoop is an open source software framework that supports data intensive distributed applications licensed under the Apache v2 license. Hadoop goal is abstract and facilitate the storage and processing of large and or rapidly growing data sets, structured and non-structured data, simple programming models, high scalability and availability, use commodity hardware with little redundancy, fault tolerant can be done, move computation rather than data. This is an Hadoop framework tools. Have the HBase activity and then Big, Hive, Scoop, Acro, and then network will be done. This is an HDFS and then MapReduce. Operating system can be used, and then backup recovery, deployment, security, and management all have been done. In this distributed with some centralization, main nodes of cluster or where most of the computational power and storage of the system lies. Main nodes run task tracker to accept and reply to the MapReduce, and also data nodes to store needed blocks closely as possible. Central control node runs name node to keep track of HDFS directories and files, and job tracker to dispatch computed tasks to task tracker, written in Java, and also supports Python and Ruby. Hadoop architectures. This is an Hadoop architecture. This is a job tracker can be divided work into task trackers. This is an Hadoop. It can be done into the name. This is a name node and this is an data nodes, and they each data node having the job tracker and task tracker. Job can be divided by the with the help of job tracker and task tracker. Okay, this is an Hadoop distributed file system and tailored to needs of MapReduce and targeted towards many reads of file streams. Writes are more costly, high degree of data replication, no need for a RAID on normal nodes, large block size, and location awareness of data nodes in networks. Okay, name node. What is the name node? It stores metadata for the files like the directory structure of a typical FS. And server folding the name node instance is quite crucial as there is an only one. Transaction log for file deletes, adds, and etc. Does not use transaction for whole blocks or file streams. Only metadata. Handles creation for more replica blocks when necessary after a data node failure. And there is a data node. Stores the actual data in HDFS, can run on underlying file systems, notifies name node of what block it has. Name node replicates the blocks 2 into local rack, 1 into elsewhere. This is an architecture and MapReduce introduced. In this MapReduce concept, we have used job tracker and task tracker and MapReduce layer. Job tracker. The role of job tracker is to accept the MapReduce job from client and process the data by using name node. In response, name node provides metadata to job tracker, and then task tracker, it works as a slave node for job tracker. It receives the task and code from job tracker and applies that code on the file. This process can also be called as a mapper. Then MapReduce layer. The MapReduce comes into the existence when the client application submit the MapReduce job to job tracker. In response, a job tracker sends a request to the appropriate task tracker. Sometimes the task tracker fails or timeout. In such a case, that part of the job is rescheduled. And this the client will be sent to the data node and the data node will be name node will be assign the work to the data nodes, and then data node will done the works, and then we have to send back to the name node, and then client will be receive the data. MapReduce engine, job tracker, and then task tracker. Job tracker splits up to the data into the smaller task, map and send to the task tracker processing each node. Task tracker reports back to the job tracker node and then reports on the job progress and send data, reduce or request in new jobs. None of these components are necessarily limited to the using HDFS. Many other distributed file system quite different architecture works. Many other software packages besides Hadoop MapReduce platform to make use of HDFS. In HDFS user, most organization handle big data, Yahoo, Facebook, Amazon, Netflix, and more on. Okay, Yahoo search web map runs on 10,000 core Linux clusters and powers Yahoo. Okay, FB Hadoop cluster holds 100 plus PB of data. Three main applications of Hadoop: advertisement and searches and security. Advertisement is mining user behavior to generate the recommendation. Searches group related documents. Security search for uncommon patterns. This is a design requirements. Okay, integrated display on email, SMS and chat messages between the pass and group of users. Strong control over who users receive message from. Suited for production use between 500 million of people immediately after the launch. The system requirements: high write out throughput, cheap elastic storage, low latency, high consistency, disk efficient, sequential and random read performance. This is an Hadoop advantages: minimum network traffic, and then cost availability, scalability, flexibility and speed, fault tolerance and high throughput. That's all about the Hadoop. Thank you.